this is what you'll see here. So Ujwala, are you listening, hopefully?
Yeah.
Okay, good. Under handouts, the very last one down here is your T-table. So if you click on this one, it'll download a T-table for you. It'll either pull it up and you can download it, or it'll download it for you. So that's where you get that one. Good.
Yeah, so you can home.
Yeah. Okay, good. All right, so then let's take a look at Chapter 8, hypothesis tests. So a hypothesis test, the basic idea, and hypothesis tests are really the most important and kind of the hardest part of this class. Just not necessarily the hardest part. A lot of people don't find it that hard, but it's kind of what the holy grail. So we're kind of building this whole thing up for. A hypothesis test, it's a test to see if your sample is unusual or not. So, again, usual will be in here, unusual will be these areas out here. So this one's a two-tail test because you could be, either two sides. There's a left tail, there's a right tail. Either one of those would be considered unusual. So this is a hypothesis test. And then also, this would be one-tailed. So we only care about this side being unusual or not. So do you guys remember when I tortured you all and had you guys draw cards to see if you could get, if you drew a black card, you'd get a chocolate truffle? This is the whole point of that one. The whole idea of this is we're going to assume that my deck is a normal deck. It's a regular deck. If my deck is a regular deck, then what do we got? We got like 7 red cards in a row. Is that unusual or not unusual? Totally unusual, right, to get that many red cards in a row, assuming my card's a regular deck. So because we got something unusual, then we said, whoa, wait a second. I think that your deck, Ms. Young, is not like everybody else's deck. Your deck is different. So that's kind of what we're doing. We're taking a sample. If we get something unusual, then we kind of say, oh, ours is not like everybody else's. Ours is different somehow. So the null hypothesis says that my mean is exactly the same as everybody else's mean. That's what this says. It says that my deck is the same as the rest of the world's deck. In other words, in our example, my deck, are you guys here? Can you guys kind of give me just a quick, hello? Because this is kind of the important part. And I want to make sure that you guys are all, okay. Okay, good. Okay, thank you. Cool. Thanks. Yay. Awesome. I feel better. It's so sad, but I can't hear you guys or see you guys. Thank you. All right, cool. So again, if my sample falls in the usual range, then I can't really say that mine, then I have to kind of accept that maybe mine is the same as the rest of the world. But if I get something unusual, something way out over here, then I have to say, look, my mean is not the same as everybody else's mean. My mean's different. And I would reject the null hypothesis because it says, my null hypothesis says mine is the same as everybody else's. And I'd say, no, Ms. Young, your deck is different. It's not the same as everybody else's. Your deck is fixed. Because we got something unusual. We got 6 red cards in a row. So we're able to say that my deck was fixed. It's not the same. And we would reject the null hypothesis. Here's another example. Say my friend gives me a coin, and I flip it 10 times, and I get 9 heads. So first of all, if I flip a coin 10 times, what proportion of heads do I expect to get in general? What proportion of heads do you expect to get when you flip coins? Anyone?
25.
Yep, 50%. That's what we expect. So we're going to look at the Rossmann chance one-prop applet to see how unlikely that is. So everybody, if you can't, that's okay. But if you can, try to open up the internet. So we're just going to go ahead and do that. And eventually, maybe. And I'm going to Google Rossmann chance applet. We've done this before earlier in the semester. So I'm just going to type in Rossmann chance applet. So Rossman Chance applet. And it's going to take forever because I'm on Zoom and doing a bunch of other things. If you can't do it, that's okay. Don't worry about it. But try to. And we're going to go for the one proportion inference. So Rossman Chance applet, one proportion inference. Check on that one. And we're going to flip a coin. So the one prop applet, Rossman Chance. So what's the probability of heads? Typically we said 50%, right? And then how many times did I flip the coin? In my thing I flipped it 10 times. Do you guys see that? I flipped the coin 10 times. So we're going to flip it 10 times. So I'm going to go ahead and I'm going to turn off animate because it'll go faster that way. I'm going to draw my samples. So here I got 4 heads. And if you look down below, you'll see a little notch under the, whoops, it didn't all come in. Let's see. Under the 4. If you guys can see it, okay. But here under 4, there's one thing. If I do it again, draw another one. Oh, 4 twice in a row. That's unusual. 4 times 3 in a row. That's crazy. And then I get a 9. Ooh, I got a 9. So I got 9 heads. So it can happen. Do you see how that totally happened right now? I got 9 heads on my 4th try. So it absolutely can happen sometimes. I'll do it again. I got 3 heads. You can see them coming in here. Now I'm going to do a total of, I have 5 so far. I'm going to do a total of 1,000. So I'm going to do 995 more. So however many you've done, subtract that from 1,000 and do that many more. So it's going to do all of them at once. And you'll get this little thing like this. Looks sort of like a normal curve. And we want to know what proportion is more than 90%. So greater than or equal to 90%. So 90% or more, 0.9. So that's a point, that's 0.9 or more. And I'm going to count that. So I had 17. I had a lot. I had 17 out of 1,000. So you can see that's just a little bit over 1%, like almost 2%. That were 9 or more. What did you guys get? Clayton, Yusur, Rihanna, Ivana, what did you guys get? What proportion of heads? Anybody? Was anybody able to do this? No? Anybody? At all? How many heads did you get out of 1,000? You got how many? How many?
13.
13? Yeah, 13 out of 1,000, so 1.3%. So you guys will get somewhere between like 0.6% and so somewhere around right around 1%, right? Definitely less than 2%. So if we kind of look at this, is that likely? Is it very unlikely? Well, what do we get? So first of all, my null hypothesis is that always that yours is the same as everybody else's. So my null hypothesis is that my proportion is the same as everybody else's, 50%. We got about 1%, maybe 1 to 2%, right? Maybe we'll put in 1.5%. There were 9 or more heads, which is similar to a p-value. We'll talk about p-values next time. But let me ask you this. What's our guideline of unusual? Our general guideline for unusual in statistics is
5% or less.
Yep, 5% or less. So is this unusual? 1.5%? Is that 5% or less? Absolutely. It's way, significantly less than 5%. So this is unusual. Is it possible that my coin is the same as everybody else's? I just happen to get 9 out of 10 heads. Is that a possibility? Yes, it's possible. But is it likely? It's not very likely at all, right? So what do you guys think? Do you think my coin is the same as everybody else's coin, or do you think my coin is a fixed coin? My friend gave me a fixed coin, like a one that comes up heads more often than tails. What do you guys think? Okay, if we're, what do you think? My coin is the same. or is it different?
I think your coin's the same. Can you tell me where we're at?
Yeah. We're not in the notes right now. I'm talking to you. I'm just giving you guys a side part here. So,
Okay.
so if I got 9 out of 10 heads when I flip it, I got 90% heads. What percent of heads do I expect to get?
50%.
50%. I got 90%.
This is unusual.
So how likely is it to get 90%? It doesn't happen very often that you get 9 out of 10 heads. So what we just did a second ago is we flipped 10 coins 1,000 times. That was the little thing I just did a second ago. We flipped 10 coins, and then we flipped it 10 coins again, and flipped 10 coins again, and counted how many heads we had. We only got 9 heads 1.5% of the time. So is it really unusual to get 9 out of 10 heads? What do you guys think? Is that unusual?
Yes.
Yes, it's very unusual.
Unusual.
So because we got something unusual, something that happens 5% of the time or less, then we would say that we would reject H0. Reject it. Because we got an unusual result. So I would say that my coin is probably not the same as everybody else's coin. Because if it was, I probably wouldn't have gotten 9 heads. Is that making sense for people?
And so we are rejecting null hypothesis.
I'm sorry?
We are rejecting
Yeah.
hypothesis.
We are rejecting the null hypothesis. Because we got 9 heads out of 10. That's rarely going to happen. So it's more likely that my coin is a funny coin. My coin is a fixed coin. Right? My friend gave me this fixed coin that comes with heads all the time. Is that sort of making sense? So you guys think back. Do you guys all remember when I brought in a whole thing of truffles, chocolate truffles, and said, if you can draw a black card, you get a truffle? And we had a whole bunch of... Right, and no one got a black card. It came red card, red card, red card, red card, red card, red card.
You're the fake bet.
Maybe, right? Why? Because getting 6 red cards in a row, you should get about 50% of them should be red. You guys, or 50% of them should be black. Instead, I didn't get 50%. I got 100% of them being red cards. So the fact that the probability of getting red, 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 red was like 1%. It was unusual. So instead, we rejected the null hypothesis. The null hypothesis said that my deck was the same as everybody else's deck, right? 50% red, 50% black. We rejected that and said, Ms. Young, you have a fixed deck because we got something unusual. So that's the whole idea. If you take a sample and your sample is really unlikely, unusual, then you reject the null hypothesis and say that so there's probably something else going on. Because again, remember, the null hypothesis says that my proportion is the same as the rest of the world's proportion. It's in this range here. My proportion is the same as this guy here. So which means I should get something in this range here. If I get something way over here, in this range over here, that means that it's very unlikely. So probably my proportion is different. I have it's going to be way over here. Like Ms. Young only had like 2 black cards in the whole deck, right? Or something like that. All right, so let's just review this real quick. So remember, P0, that's the population proportion. In other words, it's all decks, all card decks in the world. So rejected null hypothesis says that either my sample randomly happened to be unusual, just we happen to have drawn 6 red cards in a row, which could happen, or we happen to flip 9 heads in a row, which could happen, or my population is different. My coin is different. My deck is different. It's not the same as everybody else's. So you're comparing your population, your deck, or people who take your drug to the rest of the world. And if you get something unusual, if you get a sample that's unusual, then you reject the null hypothesis and say that your sample is, that your population is different than everybody else's. That's the key thing. So if you get that, then the rest of this is going to be real easy. So hopefully you guys are paying attention to that and got that. Do you guys want to talk about that some more, or ready to move on a little bit? Okay, I'm getting no answers here. Clayton, go ahead and read this. Clayton, B.
A statistical hypothesis is a claim about a population parameter, which may or may not be true. The null hypothesis, denoted by H.
H naught.
So
That's H called H naught.
H naught is a statement that the value is a population parameter, such as proportion, mean, or standard deviation, is equal to some claimed value. Example, there is no difference between 2 parameters. My mu equals
The population mean.
naught,
Good.
or my little p equals a little p naught. We test the null hypothesis directly in the sense that we assume that it is true and reach a conclusion to either reject H naught or fail to reject H naught.
Good. So again, null hypothesis is called, it's right here, H sub 0, and it's also called H naught. It's not like it's N-A-U-G-H-T. It's this kind of knot, that knot there. Have you guys ever heard the phrase, all is for naught? It's like this English phrase. It means all is for nothing. So it's an English word, it means nothing. So now it's H sub nothing, H sub 0. Null also means nothing. So what this means is this null hypothesis is nothing, no difference, nothing difference. The difference is nothing. So if there's no difference between 2 things, then they're equal. If there's no difference between 2 scores, then you have the same score, they're equal. So in other words, my mean is the same as everybody else's mean, the world's mean. Or my proportion of red cards is the same as everybody else's, the world's proportion of red cards. So that's the null hypothesis. It's always that your mean or your proportion is the same as everybody else's. And then what we do is we test that null hypothesis, and either we reject it or we fail to reject it. But that's what we're looking at, is we're trying to prove or disprove that they're equal. There's also an alternative hypothesis. Ian, can you read this one? Just read it from here. Go ahead.
The understanding hypothesis being denoted by H1 or H8.
Is this Ian or is this it sounds like Ujwala.
Yeah.
Okay. I think Ian's having trouble. Megan, can you read instead for him? I think Ian's having trouble with his microphone.
The alternative hypothesis denoted by H1 or HA is the statement that the parameter has a value that somehow differs from the null hypothesis. The symbolic form of the alternative hypothesis must use one of these symbols. So
Less than.
less than, greater than, or not unequal to.
Yep, exactly. So the alternative hypothesis, either you have H naught or something else. if H naught is always, always, always equal, and let me say that again, H naught is always, always, always equals, then the alternative can't be equals. It has to be something else. Less than, greater than, or not equal to. So here, I want you guys to circle the ones that could be null hypotheses and box the ones that could be alternative hypotheses. So take a minute and do that. Go ahead. And I'll randomly call on people to give me the answers, so be prepared. I'll put the chat open also, so you can answer via chat if you would prefer. So again, look at your notes. Null hypothesis is always, always, always equal. Alternative is going to be greater than, less than, or not equal to. All right, so let's go ahead and take a look at these. Ian, do you want to go ahead and type in your answer to the first one in the chat, whether you circled or boxed it? Okay, so if it's null, then you would be null should be equal to, or should it be something else that is greater than, less than, or the other? Null is always, always, always what, guys?
Equal.
Equal. So that's going to be, this is an equal, so this should be a circle. Good. And then the next one, Eba. What's the next one? This one over here? I'm guessing people want to, you can chat it as well if you want. Eva, are you still there? Or Jackie, can you give us the answer to the next one, Jackie? This one here?
This box.
Yep, thank you. And then Mahika, can you give us the next one?
Yeah, I boxed it as well.
Yep, because it's not an equals, it's something else. Chris, next one.
Box.
Great. That's also not equals, it's a box. Samantha, the next one. Circle. Yep. And then the last one, Robert. You can also chat it if you're having trouble with your thing.
He's in the chat as well.
I don't see him. Oh yeah, box. Got it. Perfect. Good. Yep, great. Nice job, everybody. All right, because again, null hypotheses are always, always, always equals. No difference. All right, so then let's go ahead and take a look at some of these. For the two-tailed tests, let's get some readers here. Sorry, you don't want to listen to me all the time. I'm boring. Michael, can you go ahead and read? Oh yeah, I'll go and do this one. These are actually pretty straightforward. So, two-tailed test, your alternative, remember your null is always going to be equals, always. So, for a two-tailed test, the alternative hypothesis is going to be not equal to, because two-tailed not equal to means it could be less than over here, or it could be greater than over here. So if it could be less than or greater than, then it's not equal to, right? Because not equal to means either, if you're not equal to something, either you're less than it or you're greater than it, right? Like in other words, if I say I don't have 2 dogs, that means I can either have less than 2 dogs or more than 2 dogs, right? So two-tailed, less than or greater than, not equal to. And remember the alpha, so say if this is 95% on the inside, then my alpha would be the rest of it, 5%. And if it's two-tailed, that gets split equally half and half here. The alpha gets split between the two portions. If it's left-tailed, whoever that is, if you can mute your microphone, that'd be great, because we're getting some feedback. If it's a left-tailed test, that's when you're claiming that something is less than. So if your claim is less than, then it's going to be left-tailed test, and it's going to be over here. So this is less than, that's left-tailed. And similarly, right-tailed would be greater than. If you're sort of claiming that something is greater than, that your mean is greater than the rest, then you're trying to say that it's over here somewhere on the right side over here. And that's going to be right-tailed. Okay, so here, problem 2 in the worksheet, just indicate, don't worry about the null hypothesis, just worry about the alternatives, and indicate whether they are left-tailed with an L over the top of them, right-tailed, put an R over the top of them, or two-tailed and put a little 2 over the top of them. So just take a minute and indicate those. 30 seconds. Go ahead and do it in 30 seconds.
It was really hard to hear you because you could hear a lot of background noise over the voice.
I know. I can just go ahead and mute everybody. I could do that. Should I just do that?
Yeah, because we couldn't hear the last few things that you said.
Okay, let me go and go over those again then. So again, two-tailed is when when your claim is that your mean is not the same as everybody else's mean, and if they're not equal to, that means it could be either less than or greater than, right? Because if I say that the number of dogs I have is not 2, I don't have 2 dogs, that could mean I have less than 2 dogs or more than 2 dogs, either one of those, two-tailed, right? So it could be either something over here on the greater side or the less side. If I'm saying, if my claim is that my mean is less than the rest of them, then it's definitely left-tailed. It's over here. We're saying it's on this side. And if my claim is that my mean is greater than the rest of them, then I'm saying that my mean is over here on this right side. So it's going to be right-tailed. So you guys, again, indicate, don't only worry about the alternatives, not the null hypotheses, but these 4 alternatives, indicate whether they're left-tailed, right-tailed, or two-tailed. I think you're probably okay. I'm not sure who it was that was making noise.
Are the ones that are equal to also two-tailed? Like was that part of that drawing that you did?
Yeah, so if the thing about it is that the equals part is always the null hypothesis. That's a good question. So the null hypothesis is always equals. So since the null hypothesis is always equals, we can't really say whether it's left-tailed or right-tailed or two-tailed, because every single one is always going to have an equal to. Do you see what I'm saying? The null hypothesis is always going to be equal to. So every single test will have an equal to part. It's just the alternative that determines whether it's left, right, or two-tailed. Does that kind of make sense?
So then do we, okay, so I didn't realize it was only asking for the alternative hypothesis.
Yeah, right. So we're only looking at the alternatives. So everyone you're welcome. Take 15 seconds and finish those up. Indicate left, right, or two on these, on the ones I have not X'd out.